Okay, let's talk about this Edexcel question on the normal distribution with the healthcare centre and the patients. In particular, part D of this question, I think is quite challenging. So if you do, if you're already happy with part A, B, and C and just want to skip to part D, I'll put the time in the description where you can skip to. But I will go for A and B and C first. So healthcare claims that the time spent with the patient is normally distributed, mean of 10 minutes and standard deviation of 4, so mu equals 10, sigma equals 4. Using this model, find the probability that the time is more than 15. So this is pretty straightforward. The time is going to be normally distributed 10, 4 squared, so the probability that the time is greater than 15, I'm going to use the normal distribution function on my calculator. So what it looks like on your calculator, go to normal distribution. The lower is going to be 15 and the upper will be 1 with a load of zeros on it, right? Really big number. And you should just get 0.1056. Okay. Some patients are complaining that the mean is actually more than 10 minutes. So we've done it around a sample and we've got the sample average here. And then we're doing a hypothesis test. So this is a standard question on hypothesis testing, so you need to learn this process. It's guaranteed marks in the exam if you can do the hypothesis testing, okay? Because it does not really change. Stating hypothesis, blah, 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 test whether there's evidence, support the complaint. So I'm going to start off with H0 and H1. H0 and H1 with normal distribution are going to relate to the value of mu. So H0 is our prior thinking, previous assumption. So the claim was that the mean was 10 minutes, okay? And the kind of counterclaim, the alternative hypothesis, is actually the patients reckon that it is more than 10 minutes. Okay, so this word more, really important. That tells us that we're going to say mu is greater than 10. Okay, if they said less than, we would make mu less than 10. And if this had just something that is different to 10 minutes or not 10 minutes, I would just put mu not equal to because the question does not specify. Don't get confused with this 11.5. Okay, this is what you get when you do your experiment or when you do your sample and you take the average. In any normal distribution, in any hypothesis testing question, binomial or normal, this figure here, the outcome of your experiment, that's what you calculate the probability of. That's not appearing in your H0 and H1. Okay, so if I assume H0, then the sample average for the time, okay, so T bar, it's going to be normally distributed. We know the mu is still going to be 10, we're assuming H0. Sigma was 4 for each time. For a sample size 20, the standard deviation will change. It would be divided by the square root of 20, okay? So there's our new standard deviation here. Let's put that in red. Sigma is now 4 over 20. And with this, we can calculate the probability of that observed result. Okay, remember, you always calculate the probability of your observed. The probability that the average time is, well, we need to choose more than 11.5 or less than 11.5. In a one-tailed test, it's quite straightforward. It's more than here, so you make it more than here. I will show you, if it's a two-tailed test and you're not sure what you can do, you draw it out. You think that the average in this kind of assumption is 10, and we have seen 11.5, and you always need to calculate the smaller tail. So since 11.5 is above 10, we're going to calculate the upper tail here to the right of 11.5, so that's why it's greater than. If I had observed something like 8 down here, I would then go to the left and calculate the probability that it's less than 8. So always that small tail. Okay. And this should just be, again, your calculator. In this case, the lower bound is going to be 11.5, upper will be some big number. And you just need to remember to change sigma to 4 divided by the square root of 20, rather than just 4. Mu will still be 10. And I get my p-value 0.0468. Okay. This p-value is what you compare to the significance level. So it's a one-tailed test, so I'm not halving it. And the sig level was 5. So this is actually, Control Z. This is less than 5%. So if we are less than this significance level, we reject H0, and then for the final mark, just a statement in context. So rejecting H0 means you're rejecting the idea that mu was 10, you're accepting that mu was more than 10. So you're going to write, there is sufficient evidence. There is sufficient evidence. And if this was accept H0, you just change that to there is not sufficient evidence. Okay, there is sufficient evidence that the average time is greater than 10 minutes. Okay. Again, if this is an accept H0, you just add the word not here. Okay, so statement is pretty much the same every time. Make sure you link to the context of the question, average, let's say wait time, or average time with patient. Okay, if you just say there is sufficient evidence to reject H0, you're not getting the mark. Okay, next part. Health Center also claims that we can model with a different number distribution. This is the dentist rather than the doctor, right? So again, part CI is very similar to part A. We're just doing a calculation. Okay, so find a probability that this time is less than 2 minutes. I'm going to go my calculator. Upper bound will be 2. Lower will be negative, like 10,000 or something like that. My sigma is 3.5, mu is 5. 0.1957. Okay. 0.1957. That's I. Find the probability that t is less than 2 given that t is greater than 0. Okay. Here, you're just going to use your formula for conditional probability, this given, okay? And you just need to know this. You are given kind of a rearranged version in the formula book. So it's a probability of A given B is the probability of A and B. Okay, you don't need to write P twice here, just one P. Divided by the probability of B. In this case, t greater than 0. Okay, don't make the mistake of, because this is and, of multiplying together the two probabilities, right? It's not independent events, we can't just multiply. You need to think about the interval here. We are saying that t must be a number less than 2 and also greater than 0. That's just simply 0 less than t less than 2. Okay. Sometimes you might get questions where, you know, someone's height is more than 170, given that it was more than 160. And in this case, when you say h more than 170 and h more than 160, that's just going to be more than 170. There's no real sort of change there. The intersection doesn't restrict anything. Over here, less than 2 and greater than 0, you just write as a double interval like that. Okay, let's get rid of this. And yeah, again, it's just something to type in your calculator. So, okay, between 0 and 2, so upper is going to be 2, lower is going to be 0. I get 0.119119. Okay, I'm going to do quite a few decimal places because before I finish, I shouldn't round, right? So next bit, lower 0, upper 10,000. Again, a lot of decimal places, so I can only round at the very end. 0.9234367, blah, blah, blah. And then this all together. You could also use the store functions on your calculator if you wish. Store one option to A and one option to B. 9234367. I make that 0.128999. Okay, 0.129, we'll call it. Okay. Right. Now for triple I. Okay, let's just do the triple I down here. So explain why this may not be a good distribution or a good model for t. What this question is getting at is the fact that if you look for the answer for II, it was 129, and for I it was 196. So in this model, the probability that a time is less than 2 minutes is actually different than the probability that it was less than 2 minutes given that it was greater than 0. And in real life, every appointment, the time should be greater than 0, right? No appointment can last negative time. So the fact that these numbers change, it kind of says that this is influencing it. So it's saying that there is a non-zero probability of the time being less than 0. So I'm just going to write that the answers to the previous were not the same. This is going to suggest that the probability that time is negative is non-zero, which is absurd. Another way you could think about this, right? If you were doing a proper model where it predicted there's no chance of an appointment being less than 0 time, then this condition on time being greater than 0 in the conditional probability, right, this would not have any effect on your answer. Of course it wouldn't, right? It's not saying anything special. Every appointment is greater than 0. The fact that these are different means that this is actually a restriction. There are some appointments where t is not greater than 0. Okay. Right. Final part, D. Okay, this is where some of you may have skipped to. Dentist believes she cannot actually complete a routine appointment in less than 2 minutes. She suggests a refined model where we only include values t greater than 2. Find the median time for an appointment using this new model. Okay, so the old model here. The old model, so before I talk about the new model, old model was just a normal distribution, 5, 3.5 squared. So this is some normal distribution curve with an average of 5. Okay. Yeah. And sometimes it would produce a time less than 2 minutes. Let's put 2 here. So first of all, median. What median means is just 50% of the times predicted by the model will be more than the median. So in this case, the median is actually 5 for the old model, because 50% of the times are above the median and 50% of the times are below the median, right? And some of those times that you get may be less than 2. The new model, what we're going to do, in the new model, we still use the same normal distribution. Okay, it doesn't say any new parameters. It just says we should only include values where t is greater than 2. So I'm going to have the same curve. So 5 being the old median and 2 here. And what's going to happen is if you imagine this model spitting out, 10 times or 100 times, let's say this model spits out 100 different times, you'd expect half of them are going to be more than 5, half will be less than 5. Some of the times are less than 2. In this new model, we just chuck those away, get rid of them. So it's like if you are doing a sample and you get some results which are just clearly anomalies, right? You would disregard those values before you calculate the mean. Same thing here. Any time suggested by this model which is less than 2 minutes, we say, nope, that's not possible. And the median now will be kind of the number for which 50% of those remaining times, 50% of those allowed times are more than that value. So if I call the median m, okay, what that median is doing is it's saying that half of these remaining values should be above m, yeah, and half of those remaining values should be sort of between 2 and m. And this is cutting in 2, right, cutting exactly in 2, this kind of remaining area from 2 up to infinity. Okay, this bit here has m directly in the middle. Okay, so like to give you an example, I'm going to make up some really easy numbers which aren't correct for the question. Let's say that 10% of the times predicted by the old model were less than 2 minutes. That means 90% of the times are more than 2 minutes. And of those 90% of times, the median would be some value such that half of those 90% of times, so 45%, would be more than median, and half of those 90% that were more than 2 will be less than m. Okay, so it's cutting this 90% into 2 regions. And in words, you would say that half of the times that were greater than 2 are also greater than m. Okay, that's what I'm saying. This is a new median. We're only considering those times more than 2. Equation-wise, you could say the probability that t is more than this m is half of the area above 2. You could actually say that being between 2 and m would be half that remaining area. You could even say that being between t and m is equal to being more than m, right? Any of these equations. Let's just take this top equation just for the fact that it's quickest to do, okay? So this is our condition. Half of the times produced by this model, which are the times that are more than 2, will be above my median. I did maybe say this is how you solve it without conditional probability. You can see this as conditional probability, right? It's a time, the probability of a time being more than m, given that the time was more than 2, right? Because we're only allowed the times that are more than 2. It's 50% of them. Like this, if you rearrange this equation here, if you just use the definition of conditional, you will get exactly this, okay? But I think it's maybe just slightly easier to see this, how to get here yourself without thinking of conditional probability, because I don't think when you first see this question you automatically just go, oh well, that's obviously conditional probability, right? Okay, let's actually just solve this now. So the probability that t is greater than m has to be, well, actually half pt greater than 2. I think we've probably already calculated probability t is greater than 2 in this model. Yeah, we've done less than 2 minutes over here, part CI. Less than 2 was 1957. So more than 2 will be 1 minus that number. Okay. So the probability that the time is more than our median will be, let's do that, 1 minus 7 divided by 2. 0.40215. And now it's just a kind of standard question on doing the inverse normal. Yeah. Here's some normal distribution. The median is here. I have 40.215% to the right. On my calculator, okay, I can only do the inverse normal when I know the area to the left. So I'm going to just find the area to the left by doing 1 minus. What's that? 59785. 59785. So there's 59.785% area to the left of my median. 0.59785. And in my calculator, I always have to input the area to the left of my unknown value. And then use that in the inverse normal feature. So area is 0.59785. Mu and sigma are as before. So sigma is 3.5 and mu was, what was mu? 5. Okay. And I see the m is going to have to be 5.87 minutes. I don't know if it says to how many dp. I should put this. I'll correct to 1 decimal place. So m is going to be 5.9 minutes. And I'm done. Okay, so I know that last part is a little bit weird, but just think about what it's saying. It's saying we throw away all the times less than 2 minutes. What's the median now? So when I cut off this bottom 2% down here, whatever percent is remaining, I want to split exactly in half. Where is that halfway line? It's the value of m, such that the probability of being more than m is half of that total area I was cutting in half, which was the probability of being more than 2. That's exactly where this equation came from. You don't need to link it to conditional probability, although you can, you really can. I hope that sort of explains how you might think of something like this in an exam. I've only seen this on one question, but if it does come up, you do know. Hope that helps, and do let me know any questions.